Good evening, class. Kagna, Hansni, Nanka, Saiti, good evening, everyone.
Good evening, ma'am.
Okay, everyone. So let's conclude this chapter. Few topics are left now in this chapter. Okay. So now we need to. Okay, so could you tell me, anyone tell me what is the full form of sonar? Yes. Anyone? What is the full form of sonar? No one. Okay. So full form of sonar is, yes, this is sound navigation. And sound navigation and ranging. So basically, sonar, this device we generally use to find the distance and the direction of like underwater objects. For example, suppose we want to just find out the ocean floor, or we just want to find out the location of any submarine. So in that case, we use this device. So basically, it's a device which is used to find the distance of underwater object. Distance and direction also. And basically it works on the ultrasonic sound waves. What is the frequency of ultrasonic waves?
Below, above 20,000 hertz.
Yes, it is more than 20,000. And below 20,000, below 20 is
Infrasonic.
infrasonic, yes. And between 20 to 20,000 is sonic waves or the audible range. Okay, so why we are using these ultrasonic waves? Why specifically these ultrasonic waves only we are using in the sonar? See, the reason why we are using these waves. So first reason, because these ultrasonic waves now, they are no, they do not get absorbed in water easily. First reason. Second reason, they travel long distance. Obviously, if we want to, suppose we want to find the ocean floor. So obviously, the sound waves which we are using, they need to travel the long distance. And also, because it's based on the reflection of the sound wave, so they can reflect also strongly. Acha, we are using this word reflection. Could anyone tell me what is a reflection in terms of light? What is reflection of light? I think in last year you had this chapter, na, light reflection. And next year also you are going to have in detail. So yes, could anyone tell me what is reflection of light? Yes, Mr. Rudra, could you tell me what is reflection of light?
Ma'am, could you scroll up once?
Sure. Yes, Rudra, are we having Rudra?
Yes, ma'am.
Yes, Rudra, tell me. What is reflection of light?
Ma'am, it falls on another object and it reflects back so that we can see it.
So what do you mean by reflection? Reflection means what?
Ma'am, I don't know how to explain it.
Hmm. So you can draw the diagram and show me. Suppose there is some surface and light rays falling
Ma'am,
on the
like
surface.
it will
Huh.
be like a V
Hmm.
in the shape of a V.
No,
Or
no.
sometimes it
Light, light, not sound. I'm asking light. Reflection is same for both of the thing, light and sound. This time I'm asking light. What do you mean by reflection of light? How it occur? Just simply draw the, everyone draw the diagram and show me. Remember, in case of light, we used to have incident ray, then reflected ray, then normal, then
The
angle.
bouncing back of light from a
Ah,
surface.
yes, very good. Reflection is bouncing back of light. Everyone just draw the diagram of simple the reflection of light and show me. And label everything. The incident ray, the reflected ray, the normal, the angle of incidence, angle of reflection, everything. Just label and show me. And reflection is, as Hansni said, this is bouncing back of light in same medium.
Mom, I didn't draw it for light, I drew it for sound. Like I drew a wave, ma'am, instead of light. Well, I'm showing it on my screen.
Okay, just give me a minute. This is for what?
A wave, ma'am.
This is for wave.
Like
Acha
I,
you, acha you draw the sonar one, na?
yes, ma'am.
Okay, okay, okay. And draw for light also.
Okay, ma'am.
And put the arrow for the incident on the reflected ray.
Done.
Show me. Hmm. Yes, Rudra. Um, just a second.
Ma'am, the other one, ma'am.
Very good. Very good.
Ma'am, I also drew another one.
Just a second. Uh, and where is normal?
I have to draw one.
And
Here, ma'am, normal. This is center line.
okay, and angle of incidence?
Ma'am, we have to draw label all of that. You just said incident and reflected.
No, no, everything I mentioned.
I know you just mentioned that, so I didn't mention it. I knew the answers, but just didn't mention.
Okay. Gagna, Hansini, Saiti, quickly.
Can you see?
Oh, yes.
I don't know if you
Hmm. Yes, Hansini. Oh, very good. Well done. Oh, you mentioned point of incidence also. Very good. Gagna,
Mom, I need to draw the bouncing back of light, right?
the reflection diagram. Yes. And
Uh,
mention
1 minute, ma'am.
everything. The incident ray, reflected ray, all the things. अरे बाप रे इतना बड़ा डायग्राम. Put the arrow. Which one is incidence ray? Put the arrow. Saiti. Yes, ma'am. Gagana, you are left only.
1 minute, ma'am, drawing.
Okay. Yes, very good. Yes, Gagana. It's very good. See, now this sonar, now the principle of sonar, basically it works on two principles. Number one is the reflection of sound. And second one is the echo. Okay, so what they did, share the diagram also, just give me that. So this is basically a device which is used to find the uh, depth of the ocean, or maybe some object below the ocean, maybe some submarine. So what it did, it basically sends the ultrasonic waves into the water. Then these waves just hit the object and they return as an echo. So they calculated the time taken for the echo to return. By calculating the time, they used to calculate the distance. Okay, so what this doing, this basically it sends ultrasonic waves into water. Now these waves just hit the object or hit the bottom, and they return as an echo. So the time taken for this echo to return, basically it is used to calculate the distance. Now it is having two part. One is this transmitter and one is this.
Wouldn't echo and reflection of sound be the same principle, ma'am?
Uh, yes, echo and basically both are related to each other.
Okay, ma'am.
Okay. So it is having two parts. One is the transmitter, other one is the receiver. So transmitter, this is used to send ultrasonic waves, and receiver which detect the echo. So transmitter is used to send the ultrasonic sound waves,
The time taking
and receiver basically this receive the echo.
to
Now how it works? What is the working of this sonar?
Let me go up a little bit.
Just take a breath. Are you selling 200? Justin Bieber tickets. Oh, well, that's great. Well, let's go get some.
Nanika, mute yourself. So what is the working of sonar? So basically, this transmitter will send the waves, and where it is sending? it is sending into the sea or the ocean. Now, when these waves strike some object underwater, they will reflect back. Now, once they reflect back, this receiver will find out the echo. Now, once the receiver find out the echo, the total time between sending and the receiving the signal, that time is measured. So, the time between sending and the receiving, that time is measured. Now, what we do with this time? We just use the formula. Which formula? We know the speed of sound in water, that is V, that is 1500 meter per second. Time we get to know by this calculation, the total time taking in sending and receiving the signal, that is our T. And we can find out the distance by these two things. Okay, so what will be our distance? Distance will be Vt by 2. Okay, so this will be our formula. And why we are dividing by 2? Because d is the this is the total distance. Waves are going to the object and coming back. That's why we are dividing by 2 to get the one side distance. Clear, everyone?
Can you scroll up for a minute?
Yeah, sure. Just draw the basics of diagram. Just draw a box, write ship, then transmitter, then receiver, and put the arrow. Receiver downward and transmitter downward, receiver upward.
Ma'am, can you scroll down?
Hansni, are you done?
Yes, ma'am.
Okay. Now, what are the application where we are using this sonar? So basically, we are using this for measuring the sea depth. We are also using in for detecting any submarine. And we are also using it for navigation. Okay, so basically sonar is very useful, very advantageous for us for all these purposes. We can find out the depth of, in case if there is very large underwater distance, so it works very well in that case also. It's very accurate for navigation purpose, in research purpose, to find out any object underwater. But sonar only works underwater. It is designed for only like water environment only. We cannot use this sonar for air. So this is the limitation also of sonar. And also, if water is not clear, means if water is muddy, in that case also the efficiency of this sonar will decrease. Okay, so works only in water environment. And in case of muddy water, the efficiency, or we may say accuracy decrease. Let's do a question. Suppose we are having a sonar system and it detects echo, say after 4 seconds. Okay, and speed of water is same 1500 meter per second. So find out the depth of the water body.
Ma'am, can you scroll down?
Sure. Timing of echo is 4 seconds and the velocity 1500 meter per second. You have to find out the depth.
Ma'am, can you say it again once?
Yes, Nanika?
Ma'am, can you say the thing again? My thing was breaking. Okay, time 4 seconds, velocity 1500. Wait.
Yes.
Ma'am, is it 3000 meters?
Distance is 3000 meter. Yes.
Yes, ma'am, I also got 3000 meters.
Okay. Gagana, Hansni and Saite. Gagana, Hansni, Saite, are you done?
Yes, ma'am.
I got 3000 meters.
Hansni, okay. Gagana and Saite?
Yes, ma'am. Same
3000. Okay, 51. Okay, so just we need to put the simple formula Vt by 2, V 1500, T is, what is T? T is 4 and 2. Okay, so 3000 meter. Yes, good. Okay, so in the same way, we need to find out the answer. Questions are there. Okay, so acha, there are few more things. Just let me know what is, okay. What is loudness of sound? Yes. Could you tell me what is the loudness of the sound? Yes, anyone?
Ma'am, the loudness of the sound is how high or low the amplitude is.
Yes. So, loudness means like we can distinguish how loud the sound is or how soft the sound is. So basically, loudness depends on amplitude. Okay, so and it is directly proportional to the amplitude. So uh, if amplitude is higher, so louder the sound. If amplitude is smaller, so softer the sound. So loudness is directly proportional to the amplitude. Okay, next thing is pitch. What is pitch? Pitch basically,
How high or how low the sound is?
high or low sound is, we can say high or low, or sound is shrill or deep.
Yes, ma'am. Sure.
Huh. Okay, and pitch is directly proportional to the frequency. So means high frequency, how high pitch means sound will be shrill or sharp, and low frequency means low pitch, means sound will be deep. Okay, say for example, give me example of any high pitch sound. Uh, in case of
cricket, ma'am, cricket, animal, insect,
which insect?
cricket, ma'am, insect.
Insect. Okay. In case of suppose we are having a child or we are having an adult, so which whose voice will be high pitch voice?
Child.
Yes. Child is having higher pitch than the adult. Why? Because the vocal cords of the child is vibrating faster. That's why. Okay. And vocal cord are vibrating faster means frequency will be more. And frequency is more, then pitch will be high. Okay. So voice of child is having high pitch. Due to faster vibration in vocal cord. And one more thing, what is quality of sound? Quality or the timbre of the sound. Yes, remember anyone? Suppose we are having, say we are sitting in a concert and different instruments are there. So we can differentiate between the, suppose two instruments like flute or violin. Okay, if they are just, someone is playing on the same note, same loudness, but we can identify the difference. How can we identify? Because the quality is different. Okay, so what is quality? Quality is the characteristics which helps us to differentiate between two sound. Two sound of same loudness and same pitch. And this quality basically depends on how the wave formed by the sound. Okay, so I think we discussed all the points of the chapter. These three things, is there anything left? So this is all about the chapter. If you have any doubt, then you can ask anything. which is left, or any doubt in the chapter? Notes are done, everyone?
Yes, ma'am.
Okay. Show me notes. Rudra. Okay, very good. Any doubt, Rudra?
No, ma'am.
Clear chapter?
Yes, ma'am.
Okay. Anyone else? Hansni?
No, no, no doubt, ma'am.
No doubt. Saiti?
No doubt, ma'am.
Okay. So next class, we'll take some questions of this chapter, and after that we will move on to the chemistry. Okay?
Okay.
Okay then.
Ma'am, what
Okay.
chapter are we doing for chemistry?
The last chapter. The atom molecules.
Didn't we do that?
We did it all.
Haha, we already done that chapter, but just as you said, just the things which are will be there in next class. So we will start those things.
Okay, ma'am.
Okay, basics, so whatever required for this grade, so we are done that chapter. Or maybe the revision of the previous thing. Okay, everyone?
Okay, ma'am.
Okay then. Bye bye. Take care, everyone.